Surfaces are actually a key component on how bacteria can be transmitted through an environment. If you think about how you touch surfaces as you move around at home or maybe even in a hospital, you can think that it's very easy for you to touch a surface, pick up some bacteria, put it on another surface where somebody else can then touch and move the bacteria around, and it can create an infective risk in environments such as a hospital.
In our research group, we've got two main strands for looking at killing microbes. One is to develop these light-activated antimicrobial agents, which uses ambient light around us with special chemicals on a surface to be able to kill bacteria. Another method is to develop surfaces where bacteria find it very difficult to stick in the first place. So that covers things like super hydrophobic surfaces. And that's very similar to what's done in nature with the so-called lotus effect, where water on a surface tends to roll, and that rolling motion picks up the dirt, bacteria or viruses.
We are working on surfaces that whose dimensions are very, very small, in fact, on the nanometer scale. To give you an indication, the human hair is 10 microns, so we are working on structures that are 1,000 times smaller than this. We work with surfaces that are inspired by nature. To give you an example, we are replicating some structures that exist in the eyes of moths, and they look like nanopyramids.
Some examples of applications are in smart decorative paints. You could also see applications, particularly in things like boats and car manufacturers, where they'd like to have this sort of self-cleaning application within cars, but also in boats you could reduce the drag as the boat goes through the water.
These light-activated antimicrobial surfaces show great potential to reduce hospital-acquired infections and to remove bacteria from devices such as mobile phones, computer keyboards, and maybe even medical devices like catheters. Super hydrophobic surfaces have a great future in self-cleaning materials and surfaces. We think these surface technologies can really revolutionise how we think about surfaces.